A cannon launches a ball at a 30-degree angle and a speed of 25 meters per second. What are the horizontal and vertical components of the initial velocity? I've made a sketch to illustrate what this problem is describing. There's my terribly drawn cannon, and there's my initial velocity of 25 meters per second. I've drawn that in black. And then what I've done is draw in vertical and horizontal components of the velocity. So part of that velocity is horizontal, part of it is vertical. The angle is the only thing I haven't drawn in here. That is 45 degrees. Here's how to solve a question like this using trigonometric ratios. It's a two-step process. The first being break the initial velocity vector into x and y components on a drawing. So I've redrawn it where 25 meters per second is the hypotenuse of a right triangle. My bad, I don't know why that says. Y'all, why did I say 45 here? This is 30. Sorry. Anyhow, 30 degrees. Right? So there's my triangle as given in the problem statement. Make sure I didn't screw anything up again. Okay, I've drawn it. I broke the vector into horizontal and vertical components. Because the horizontal and the vertical are at 90 degrees to each other, I've included the right angle symbol, and I've labeled everything I know about this triangle. That's step one. Step two, set up trigonometric ratios that include velocity in the x and velocity in the y. Let's get this visible here. Let's first look at velocity in the x direction. No, I'm sorry, y direction. Velocity in the y direction, that's this side. So I'm going to look back on my trig ratios, sine, cosine, and tangent. You should have those elsewhere in your notes. Look at them. Find one that involves v sub y. I'm going to use the sine ratio. The sine of angle theta is equal to the opposite side length divided by the hypotenuse length. Sine of theta is Vy over V. Filling in the numbers, we've got 30-degree angle, 25 meters per second. Next step. Last step, I'm going to multiply both sides of this equation by 25 to clear it out of the denominator. 25 times the sine of 30 degrees, that's the y velocity. You do that on your calculator, you're going to get around 12.5 meters per second. Cosine, on the other hand, cosine, by definition, that ratio is the side adjacent to an angle divided by the hypotenuse of the triangle. So the cosine of the theta, the unknown angle, is the x component of the velocity divided by the overall velocity. Filling in the numbers we've got, solving as before, we get a v sub x of around 21.7 meters per second. That matches my expectation of a world where this angle is 30 degrees. I would indeed expect Vx to be bigger than Vy because this is a relatively small angle. My picture's not to scale. Now, side note, as long as you draw a triangle that looks like mine in that it has an angle theta in the lower left corner, the ratio, the solutions for the components, the ratio setups will always look like this. So if you have this picture, this will always be that is generally true. You don't have to redo all that thinking as long as you can draw a triangle with the angle theta in the lower left corner. Now it's your turn. I want you to try a problem where a basketball is thrown at a 70-degree angle and a speed of 15 meters per second. What are the horizontal and vertical components of that initial velocity? The answers are here at the bottom of the screen. Go ahead and pause the video while you work it out, and then I'll scroll. 3, 2, 1. These are the answers I get. Flip your head upside down, get them to read them. Thank you for watching the basics of how to solve for components of velocity, in this case for a projectile. Good luck on future problem solving.